Hello, CP Finite, and welcome to a new lesson here, lesson 7.1 on probability and odds. So let's get started. First off, how do you determine probability events or odds of events is our essential question. With probability, the main idea is that it's kind of like a fraction. And what it is, it's the likelihood, oh, where's my pen? It's the likelihood of an event occurring. Okay, and probability is one of the few mathematics topics, actually every mathematics topic is pretty applicable, but one that you've likely heard many times. So it's the likelihood of an event occurring, which is often represented as P of an event, and it's equal to, it's a fraction, the individual event or the number of things in the individual event over the total in the outcome. So individual over total. Key things: probability can never be negative, cannot be negative, and it cannot exceed 100. So cannot be over 100%. I know sometimes we exaggerate and we're like, oh, there's a 500% chance of it raining. That's just not proper. So can't be negative, can't have a negative chance of anything happening. The lowest probability is 0. That's just that it's not going to happen, and it can't be over 100. So let's look at one example here. A lot of times there's giveaways at concerts and games and such. So the table below represents a sample of the number of people at a Penguins vs. Flyers game at PPG Paints Arena. Fans are asked which team they are rooting for. Write your answer as a percentage, okay? First idea, with a table like this, we're always concerned with the total number of things. So I have columns here for you already to write in the total. So Flyers and Penguins added together, that's a total of 800 guys, men, at the game. 250 plus 550. No shame if you need to use a calculator. That's also 800. What do you know? Total of Flyers fans, 550. And total of Penguins fans, 1050. Okay, and also the totals in general, 1600 for both. Okay, anyway, so probability, a random guest is a fan of the Penguins. So loudspeaker comes on, hey, if you're a fan of the Penguins, you get a prize, something like that. All right, so the main idea is if we're picking a random guest, all right, and they're liking the Penguins, we're looking at the total number of Penguins fans. Okay, so that is the individual event, and there's 1,050 over the total number of fans there, over 1,600, and we are going to represent percentages as a decimal, so 1050 divided by 1,600, bada bing, that is 0.656. You can round to the nearest tens, hundred, thousandths. Please write it as a percentage, which is simply moving the decimal 2 spots, 65.6%. All right, there's a 65.6% chance that they like the Penguins. Okay, we get a little more specific here. What's the probability a random male, okay, from the sample liked the Flyers? So now we're really just looking at the guys in the sample here, so the men, and that they like the Flyers, okay? There are 300 guys that like the Flyers, and total guys at the game are 800, so it's 300 over 800, which is really 3 divided by 8, or 0.375, which is 37.5%. So it can be tricky as to what your denominator is. Okay, that's the total number of things in that particular case. Numerator should always be smaller or the same as the denominator, never bigger. What's probability a random guess did not like the Flyers? Okay, so did not like the Flyers. There's a few different ways to think about this. That means that they did like the Penguins. Okay, so if they didn't like the Flyers, that means they must have liked the Penguins. So really, it's the same problem as number one. Did not like the Flyers, that means they liked the Penguins. So there's 1050 all over 1600, which would be the same as number one, 65.6%. Another way to do it is if we find the number that liked the Flyers. All right, so that's 550 over 1600 divided by 1600. Okay, and we get 0.344 about. Or 34.4%. Notice that it's opposite if we subtract from 100. So if now we do 100 minus 34.4, we end up with the 65.6. Okay, we call that complementary probability. We'll talk about that a little more later. Whichever way you want to consider that problem, did not like the Flyers, means they like the Penguins, or vice versa. You can do that. What is the probability of selecting a woman that likes the Flyers from the sample? So now we're looking at the ladies, that they like the Flyers. So total women are 800. Those that like the Flyers are just 250. Okay, these ones here. 250 divided by 800. Bada bing, bada boom. That's 8,000. Sheesh. Is 0.3125 or 31.3%. Okay, so just be careful with those types of things. The next concept are odds. And odds, all right, the formal definition is, so there's actually two different types. The odds for an event are the number of favorable outcomes for that event versus or over the number of unfavorable. So now it's not the total, it's just a number. So number of unfavorable over number of favorable. So odds for, favor is up top. Odds against is just opposite. Okay, so I'll give you these for the first few examples, the first few practices. You just want to work through them. Our definition, it just changes depending on which one you have. So let's just look at an example. Example of odds. A box contains 30 ripe bananas. Those would be yellow nanners. 15 rotten bananas. Those would be our brown bananas. And ripe bananas, unripe bananas, those are the green ones you're not quite ready to eat yet. You reach in the box and grab a banana, and we want to know the odds, and we're going to write the answer as a reduced ratio. So the odds for it being ripe. So we have 4, the odds for it being ripe, which means it's the number of things we want over the number of things we don't want. Well, the number of things we want it to be ripe, and there are 30 ripe. So it's going to be 30. Now, the number of things that aren't ripe is 20. Well, how did I get that? Well, there's 15 rotten and 5 unripe, so there's 20 other things. So 30 over 20, we would say that's 3 over 2, or odds oftentimes is 3 to 2. That's how you write them as a statement of odds. 3 to 2 are the odds. Okay, odds against an unripe banana. Okay, so this can be a little tricky as well. Odds against, so now we want the number of things that aren't unripe. Okay, so odds against an unripe banana. Well, the number of unripe bananas are 5, so that is actually down below. And against is everything else. So that would be 45. So 45 things are not unripe, and 5 things are unripe. So 45 over 5. Just 9 over 1. Okay, and we would just say that's a 9 to 1 odds against it being unripe. The odds for the banana being rotten. So we want rotten up top. And rotten would be 15. And we want everything else down below. So everything else would be 45. Not 45, 35. 15 over 35. Okay. Write it as a fraction this time, reduced fraction, 3/7, or 3 to 7. Okay. And the odds for the banana being ripe or unripe. So 4 means we want the thing that's mentioned up top. So ripe or unripe. Well, there's 30 ripe, 5 unripe, so 35. We want the things that aren't down below. There's 15. So it's the opposite, essentially, of the one up top. And 7 to 3. Okay. So odds can be tricky. Odds against, just think that, so like with the unripe banana, against means your subject, so to speak, is in the denominator. For your subject is in the numerator. Okay, so be careful with those ratios for odds, percentages for probability, and just do your best, of course, and try out some of the practice problems. Great job.